Hello everyone, what's going on? Today we are going to learn Lenz's law. Lenz law. Before Lenz law, you should know about Faraday's law because Faraday's law and Lenz's law are linked each other, right? So before Lenz's law, let me remind you the Faraday's law, right? Basically, Faraday's first law states that if there is a coil and there is a bar magnet, right? If we take it a state constant, then there is no EMF is produced in the coil. If we move it either towards or upwards, then EMF will produce, right? It is Faraday's first law. And Faraday's second law states that how means the magnitude of EMF which induced by the changing of magnetic flux, right? I hope if you didn't understand, then you should go previous video of mine which I described very clearly in Faraday's first law and second law. So in Lenz's law, we know or we describe about the direction of current flowing, right, in the coil. So let me write down first the definition. According to Lenz's law, the polarity of the induced EMF of the induced EMF. I hope you know the full form of EMF, right? Yeah, that's very easy and there is no doubt, right? Electromagnetic force or electromotive force, right? EMF is such that it opposes the change in magnetic flux. It opposes the change in the magnetic flux responsible for its production. Right? Basically, it states that the direction of the current flowing in the coil, right? So, first you have to know the right hand thumb rule, right? If consider this is a coil, if the current is flowing in anti-clockwise direction, right? So what will be the magnetic flux direction? You have to know what I said. Right hand thumb rule, right? If the current flowing anticlockwise, then the magnetic flux will be outward, right? If anticlockwise, then if there is the current flowing of the direction will be clockwise, then what will be the magnetic field direction will be inward, right? Now if we take a coil, right, and a wire magnet, there is north pole and south pole, right? If we move towards the coil, then what kind of direction should be flow in this coil? In this coil, there have two flows in anti-clockwise direction, right? Why? Because if we take it towards the coil, right, then it's how or which type. That means, I mean to say, there is should it opposes the change of magnetic flux, right? So if there is north pole, that then it is opposites. If there is north pole, then it should be outward or anti-clockwise direction, right? So the direction will be anti-clockwise. Let me repeat. Lenz's law states that the polarity of the induced EMF is such that it opposes the change in the magnetic flux responsible for its production. I mean to say, that kind of direction should have which opposes the magnetic flux, right? So if we if the direction will be anti-clockwise, then it also opposes the bar magnet move, right? So let me give another example. If there is another coil and there is another bar magnet, right? If we move the bar magnet outward to the coil, right? So what kind of the direction will should have the the electric field in the coil? It will be clockwise, right? Sorry, yes or no? If we move it outward the coil, then there is the electric field will have clockwise direction, right? If clockwise direction, then it offers to, because if it flows in clockwise direction, then it in the electric field or magnetic field will inward, right? That means it attracts inwardly if we move it, so it opposes, right? I hope you will understand. So thanks for watching. Tata, take care all of you.